Okay, आजको यो सानो भिडियो will be on the regulation of acetyl-CoA carboxylase. Okay, so this enzyme acetyl-CoA carboxylase is the rate limiting step in fatty acid synthesis. Okay, and this carboxylase enzyme converts acetyl-CoA into malonyl-CoA. Okay, and this enzyme that is involved in the conversion of acetyl-CoA into malonyl-CoA require vitamin B7, that means biotin, as a coenzyme. Okay, and this is the regulatory step also in fatty acid synthesis. Okay, and it is under the control of the hormones. Okay, mainly the insulin and the glucagon. Okay, so acetyl-CoA carboxylase enzyme, it is activated in the dephosphorylated state. Okay, and it is deactivated in the phosphorylated state. Okay, now since insulin is a anabolic hormone and fatty acid synthesis is an anabolic process, the insulin promote the dephosphorylation of acetyl-CoA carboxylase. That means insulin activates the phosphatase that dephosphorylate acetyl-CoA carboxylase. Now, since dephosphorylation of acetyl-CoA carboxylase render it active, the insulin activates the phosphatase enzyme. Whereas the glucagon, okay, which has a different function from that of the insulin, okay, it phosphorylates the acetyl-CoA carboxylase. Okay, now glucagon, which is a peptide hormone and it is a catabolic hormone. Okay, the insulin, it is secreted in the well-fed state and the glucagon, it is secreted in the hypoglycemic state or during the low blood sugar level. Okay, so what happens is the glucagon, after binding to its receptor, activates an enzyme called as adenylate cyclase, and that adenylate cyclase converts the ATP into CAMP. Okay, now the CAMP activates the CAMP dependent protein kinase, that is the protein kinase A. Okay, now this CAMP dependent protein kinase activates the AMP kinase. Okay, the AMP kinase then phosphorylates AMP kinase. Okay, and this AMP kinase again phosphorylates the acetyl-CoA carboxylase, making it inactive. Okay, the overall process of the glucagon is the glucagon after binding to the receptors, okay, activates the enzyme adenylate cyclase. The adenylate cyclase converts ATP into CAMP. CAMP then activates CAMP dependent protein kinase. The CAMP dependent protein kinase activates the AMP kinase. Now the AMP kinase activates, phosphorylates the AMP kinase, that makes it active. Okay, and AMP kinase then phosphorylates acetyl-CoA carboxylase, which makes it inactive. Thank you.